First of all, I welcome all the students and the participants who are attending this live lecture. Now see this, in this today's live lecture, we shall discuss the theory regarding homogeneous equation with analytic coefficient. See this. That means in that ordinary differential equation, we shall discuss the homogeneous equation with analytic coefficient. So, the equation, which type of equations are called as analytic coefficients, how to solve the problems based on these analytical coefficients, now we shall discuss, and then we shall study what is meant by the Legendre equation. Which type of equation is called as a Legendre equation, how to obtain the solution of a Legendre equation. This is the totally theoretical part which we have to study. Okay, and after completion of this theoretical part, I shall send you the notes regarding this. Then you can write that notes. I will send that notes on the WhatsApp. Okay, because this analytical homogeneous equation with analytical coefficients, analytic coefficients, then Legendre equation, these are the totally theoretical part. That means we have to understand the concept. Okay, now see this, we shall see both on this. Now suppose homogeneous equation with analytic coefficient. If suppose G is a function defined on an interval I, a point x naught, we say that G is analytic to x naught, can be expanded. See this, analytic on expand can be expanded. 1 minute, I think यहाँ पे कुछ spelling का मसला है. See this, expanded. So x naught can be expanded in the power series of x naught. See this, analytic function G can be expanded to x naught. See this, power series of x naught which has a positive radius of the convergence. This is the concept you must know. If G is a function defined on an interval I containing a point x naught, we say that G is analytic to x naught, can be expanded or can be expanded in the power series about x naught, in the power series about x naught which has a positive radius of the convergence. Thus, G is analytic at x naught if it can be represented in the form of G of x is equals to, see this is the analytic function G of x, which is equals to summation k is equals to 0 to infinity Ck into x minus x naught bracket raised to k. Okay, where Ck is a constant and the series converges x minus x naught which is less than r naught, where r naught is greater than 0. See this, all the derivative exist on x minus x naught which is less than r naught, and they may be computed by differentiating the series term by term. That means if suppose G of x is equals to, this is the analytic function, that is k is equals to 0 to infinity. If we put k is equals to 0, then we get C0, x minus x naught bracket raised to 0 means 1, that is the first term is C0. Second term is, if k is equals to 1, then C1 is equals to C1 into x minus x naught bracket raised to k means again 1. In this way we can obtain this. Now this convergence, all the derivative exist if x minus x naught on x minus x naught is less than r naught. That is the radius of convergence. What is mean by r naught? R naught is the radius of a convergence. So we can differentiate this equation 1 g of x, see this, then we get g dash of x is equals to summation over power multiple मध्ये घ्या, that is k into ck into x minus x naught bracket raised to k minus 1. So this is a g dash. Again, if we differentiate this g dash with respect to x, then we get g double dash, which is equals to summation k is equals to 1 to n k into k minus 1 k minus 2. In this way we can up to ck into x minus x naught bracket raised to k minus 2, and the differentiated series converges on x minus x naught, which is less than r naught, that is radius of the convergence. The coefficients a1 comma a2 dot 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 an of L are analytic to x naught, then it turn out the solution. Okay, thus the solution can be computed by the algebraic process. See this one, existence condition or existence theorem for analytical coefficient. See this is the condition for the existence of the result, existence of the solution to the analytic coefficient. See this, you know what is mean by analytic? सांगा बरे स्टुडंट, तुम्हाला झालेला ॲनालिटिक बऱ्याच वेळा झालेला आहे, BSc ला पण झालेला आहे. कॅन यू टेल मी व्हॉट इज मीन बाय ॲनालिटिकल कोएफिशिएंट? ओके, नाउ लेट x0 be a real number and suppose the coefficients a1 comma a2 dot 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 an in L of y, y raised to n minus y raised to n, that is yn, plus a1 of x y n minus 1 plus dot 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 an y. Suppose this is the differential equation with analytic coefficients, homogeneous. Actually this is the homogeneous. See, this main heading is homogeneous, so we can write this homogeneous differential equation with the analytic coefficients. Here we can write this 0. Here's a convergent power series expansion in power of x minus x naught on an interval such that x minus x naught is less than r naught, that is the radius of convergence, and r naught is greater than 0 because it is the radius of a convergence. So if alpha 1 comma alpha 2 alpha 3 dot 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 alpha n are any n constant, then there exists a solution phi of this problem. Suppose this L of y which is equals to L of y which is equals to okay 0, y of x naught is equals to alpha 1 dot 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 y raised to n minus 1 of x naught is equals to alpha n. In this way we can find the solution of the equation. चला answer आलेत, I will see it. बा बोळेगावे सारिका बोळे, the function which is a differentiable as well as a continuous at everywhere is called analytic function. Very good. Coefficients are real number. ठीक है. Okay, coefficients means analytic coefficient means the coefficients of real number, and analytic function means which is a differentiable everywhere. Very good. Okay, Anuradha Giri, very nice. Which is a differentiable, that function is called as a differentiable, mean analytic coefficients. Okay, that is a real number, no problem. Okay, बरोबर आहे, म्हणजे माहित आहे तुम्हाला, no problem. We shall discuss one example based on this. आता याच्यावरचे एक example आपण घेऊ with the series. See this, we can find the solution L of y is equals to 0, y of x naught is equals to alpha, and y raised to dot 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 y raised to n minus 1 of x naught is equals to alpha. Under this initial condition we can find the solution with the power series phi of x is equals to summation k is equals to 0 to infinity ck in a bracket x minus x naught raised to k. This is the power series expansion of the solution phi, okay, which is convergent for x minus x naught is less than r naught. So we have this is the process. Actually this is not necessary to write this. This is the only convergent for x minus x naught is less than r naught. You have to write this, okay, where Ck for k is greater than n may be computed in the form of the coefficients C1 comma C2 C0 C1 C2 dot 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 Cn minus 1, and substituting this series in equation 2, then we get the solution. See this, we consider the example. Suppose, what is that example? For example, we shall find the solution of a equation L of y which is equals to y double dash minus xy which is equals to 0. See this, the given differential equation is, we shall write, हे प्रॉब्लेम आहे समजा, याच्यात गरज नाही आहे, L of y लिहायची गरज नाही. So given differential equation is L of y which is equals to y double dash minus xy which is equals to 0. चला रे स्टुडंट सांगा याच्यामध्ये a1 of x किती आहे, a2 of x किती आहे. Now that is L of y which is equals to y double dash minus a1 of x into y dash plus a2 of x into y which is equals to 0. Therefore we can write here a1 of x is equals to 0, a2 of x is equals to, that is a minus x. So these are the analytic function, we can differentiate this. So we can hence the coefficients a1 and a2 are, hence the coefficients a1 and a2 are analytic for all real x naught. Now we have to find the solution of series. Now बराबर है, we have to find the solution series, that is phi of x. Now according to the formula we can write phi of x is equals to, what is the value of phi of x? Phi of x means, now we consider that is a, see this use this formula, phi of x is equals to summation k is equals to 0 to infinity Ck into x minus x naught bracket raised to k. So we can write k means, suppose initial condition which is, we can take x naught is equals to 0, initial solution we can take 0. We can take initial solution, that is a 0. So it satisfies the equation. Then we get the value, that is a C0. If you put k is equals to 1, x naught is equals to 0, then C0. Second term काय आहे ते सांगा बरे. If initial value is considered as x naught, that is at the center, at the origin, so we can write C1 x raised to, again if we put k is equals to 1, x naught is equals to 0, then we get the result as C1 plus C2 x square plus dot 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 up to the infinity. Now if we differentiate this, then we get a phi dash of x as like this. If the g is analytic function, see this, if g is analytic function, then that can be written as in this way. So we can differentiate g dash, g double dash in this way. So we can find the expansion series, and according to this theorem we can show it is the solution of a differential equation. So now phi of x is equals to, suppose this, now differentiating with respect to x, देन व्हॉट इज द व्हॅल्यू ऑफ फाय डॅश ऑफ एक्स, सांगा रे काय येतं फाय डॅश ऑफ, सर्व विद्यार्थ्यांनी सांगणं गरजेचं आहे. वी कॅन टेक द व्हॅल्यू ऑफ फाय डॅश ऑफ एक्स. तुमच्या समोर फाय ऑफ एक्स आहे, तुम्ही सांगा फाय डॅश ऑफ एक्स काय येईल. चला कोण सांगता आन्सर्स, त्याचे मी थोडं ही घेतो, स्क्रीनशॉट घेतो. जरा फास्ट घ्यायचे, आपला सिलेबस मागं पडतोय. हां सांगा रे डिफरन्शिएशन. खूप सिंपल डिफरन्शिएशन आहे रे. हां व्हेरी गुड समरीन खान. पास समरीन खान मी ऑब्झर्व करतो, बऱ्याच वेळा ऑब्झर्व करतो. सी दिस समरीन खानचं खूप प्रॉम्प्ट असते, खूप रेग्युलर असते, प्रत्येक वेळी विचारल्याबरोबर आन्सर देत असते. समरीन खान असो, सारिका बोळेगाव असो, ऋतिका असो, बाकीचे काय करतात मला हेच समजत नाही. आणि आपल्याकडं जवळपास AT ॲडमिशन आहेत. मी बऱ्याच वेळा सांगतो AT ॲडमिशन आहेत. 50-40 मुलं जनरली असतात. बाकीच्या मुलांना मी परत एकदा सांगतो, सेकंड सेमिस्टरचं हॉल तिकीट दिलं जाणार नाही, हे स्ट्रिक्टली मी सांगतो. ओके, वी कॅन राईट धिस साइज. सी दिस, 1 minute. ओके ओके ठीक आहे, बराबर आहे, सर्वांचं ठीक आहे. C0 means constant, that is 0. Now if we differentiate with respect to x, then we get C1 into 1 means, suppose we can write direct C1 plus 2 into C2x plus dot dot dot. Very good. We can obtain this. So this is a phi of x. This phi of x can be obtained by the concept of analytic coefficients, because here a1 and a2 are the two functions which are analytic function. So we can take its expansion series, that is by using the radius of a convergence, that is phi of x, which is equals to summation over k is equals to 0 to infinity ck in a bracket x minus x1. See this, x minus x naught bracket raised to k. In this case x naught is the initial condition. We have considered this, the value of x naught is the initial point, that is 0. See this. Okay, now we shall write, again we differentiate this, then we get the phi 2 double dash of x. Sanga re, again differentiating, then phi double dash of x, which is equals to, tell me what is the value of phi double dash of x, student, because this is the homogeneous differential equation of second order. Therefore we have to differentiate this to find the solution. Suppose phi of x is the solution, then we have to replace phi of x, phi dash of x and phi double dash of x. Actually here phi dash of x will be 0 because its coefficient is 0, a1 of x is equals to 0. So we have to put the value of phi double dash of x. तो phi double dash of x हमें पुट अप करना है. C1 की वैल्यू 0 होती है, टू टाइम्स C2 के वैल्यू 1 होते. तिसरी टर्म सांगा ना, C3 into x raised to 1, अशा पद्धतीने येईल. पुढच्या पण टर्म सांगा. So we get the result as 2 into C2 plus 3 into 2 into C3 x plus 4 into 3 into C4 x raised to 2. In this way we can obtain this. In general we can write this as summation k is equals to 0 to infinity k plus 2 into k plus 1 into ck, say this, ck into x raised to, we can write ck plus 2 into x raised to suppose k. आता याला जनरलाइज करा, this is 1, this is 2, this is 3, then we can write k plus 2. k म्हणजे इथं 2 आहे, इथं 1 आहे समजा, 1 plus 2 म्हणजे 3. suppose k is equals to 0, then we get the first term. Ela reverse kara. If k is equals to 1, then we can write 3 means 1 plus 2, 2 means 1 plus 1, then ck, 3 means we can convert this as 1 plus 2, k means 1, and x raised to k means x raised to 1. In this way, this is for k is equals to 0, this is for k is equals to 1, this is for k is equals to 2. In this way, we can write general term. Now, also we know that, अभी देखो क्या है differential equation, minus x into y. We have to put the value minus x into y. So, x into phi, y means actually x into phi. So, we can take the value also x into phi of x. Y means x. इथं ठेवायचं solution actually कसं असतं, phi is a solution. Then what we have required, phi double dash of x minus x into phi of x which is equals to 0. या फॉर्म मध्ये सोल्युशन असेल. म्हणून x into phi which we have to calculate, already we have calculated f double dash. Now x into phi which is given by phi of x is given. What is that phi of x? C0 plus C1x plus C2x square. In this way we can write the x into phi means C0x plus C1x square plus C2x cube plus dot 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 in this way. Now this can be also represented in the form of a power series, that is k is equals to 1 to infinity. आता this is the first term, k is equals to 1 to infinity, this is the first term. So we can put this as ck minus 1 x raised to k. Now if we put k is equals to 1, then 1 minus 1 means 0, this is the first term. If we put x is equals to 1, 2, then k is equals to 2, then k minus 1 means 2 minus 1, that is c1, x raised to 2. If we put k is equals to 3, means third term, we have to find out the third term of a summation. Then we get this. In this way we can write this. Therefore, now we have the solution in the form, मैं खाली लिखतो, that is L of phi which is equals to phi double dash minus x into phi, or we can write this is a phi double dash of x minus x into phi of x. Now put this value, phi double dash of x we have calculated from, suppose we can write this equation, then you will get the easy for understanding. So this is the equation number, okay, this is equation number second. Suppose this is equation number third. Then from second and third we can write, so phi double dash of x means we can write this as 2 into c2. आता हे तर 2 into c2 असेलच, but we can write this as phi double dash of x means summation over k is equals to 0 to infinity k plus 2 to k plus 1 into k plus 1 into x raised to ck plus 2 x raised to k, plus we can write summation k is equals to 1 to infinity, second is from, sorry it is a minus, I think it is a minus, हा minus है minus. So x into phi of x ची value k is equals to 1 to infinity ck minus 1 x raised to k, x raised to k. इथं 0 नाही घेता येणार, जर 0 घेतलं k is equals to 0 पासून घेतलं तर इथं निगेटिव्ह मध्ये येतो. So we can't this. Now we have to take the summation common, but first summation is from k is equals to 0 to infinity, second summation is from k is equals to 1 to infinity. Now we have to convert this k is equals to 1 to infinity. So put k is equals to 0 put first. If we put k is equals to 0, then we get 2 here ck plus, I think 2, ck plus 2. If put k is equals to 2, then k is equals to 0 अगोदर ठेवा, एक टर्म बाजूला काढा, म्हणजे k is equals to 0 ठेवून एक टर्म बाजूला काढा, 2 into c2 x raised to, आता इथं k is equals to आपण काय ठेवलं, 0 ठेवलं, x raised to 0 means 1. Okay, this is the first term. Second term as it is, summation k is equals to 1 to infinity k plus 2 to k plus 1 c k plus 2 x raised to k minus summation k is equals to 1 to infinity ck minus 1 x raised to k. So we get the summation common here 2c2. इथं summation ला कन्वर्ट करण्यासाठी आपण first summation is from k is equals to 0, second summation is from k is equals to 1. So our aim is to convert this k is equals to 0 to k is equals to 1, and then we can, after conversion, we can take the common summation. So we have to convert this k is equals to 0 to 1, replace, put the value of k is equals to 0 and take out that term out of the summation. So we get this result. सुरुवातीला k is equals to 0 ठेवलात, k is equals to 0 ठेवल्यानंतर ही टर्म मिळाली, म्हणजे 2 into c2 plus all these terms are as it is. Now 2 into c2 plus, now take the summation common, k is equals to 1 to infinity. Which are the remaining terms? That is, we can take also xk common. So which are the terms? K plus 2, k plus 1 into ck plus 2 minus, second factor मध्ये summation common आहे, x raised to k is also common, then we get ck minus 1 bracket raised to x raised to k. So now in order to phi is a solution, अगर phi is a solution है, so we can say that this is the required solution of the given equation, and we can find the series of solution. Here, if phi is the solution of the differential equation of the equation 1, then of the equation 1, that is L of y is equals to 0, that is L of y, that means is equals to 0. This implies that L of phi which is equals to 0. अगर L of y का solution phi होता है, तो we can write L of phi is equals to 0. So this is the value of L of phi. So we can write this term as a 0. Therefore, we can write 2 times of c2 plus summation over k is equals to 1 to infinity in a bracket k plus 2, k plus 1, c k plus 2 minus c k minus 1 x raised to k, which is equals to 0. And thus we can obtain the solution. This implies that the addition of two terms is equals to 0. अभी देखो यहाँ पे addition of these two terms is equals to 0. इसका मतलब होता है therefore 2 times of c2 is equals to 0, comma summation of k is equals to 1 to infinity k plus 2, k plus 1, ck plus 2 minus ck minus 1 x raised to k, which is equals to 0. See this. So we get this result. Now we can take the summation, and if, okay, See this equation, the equation 4 will be true if all the coefficients of the powers of x are 0. पहा इक्वेशन 2 ची व्हॅल्यू 0 आहे, पण या इक्वेशन 2 ची व्हॅल्यू 0 कधी येऊ शकते? All the powers of x must be 0. So we get, from this we can write 2 into C2 is equals to 0, comma k plus 2 into k plus 1 into ck plus 2 minus ck plus 1, which is equals to 0, because the powers of all the powers of x is equals to 0. Then we can say that the result of this equation is equals to 0. So we can find the solution. Thus we can obtain the solution. This gives an infinite set. See this. This gives an infinite set of equations which can be solved for ck, which can be solved for ck, आणि असं set of equation मिळेल, and thus we can find the solution, and thus we can find the solution. See this, in this way, this is the process for finding the solution of equation by the analytic method. Suppose this is a differential equation. We shall see this again. I shall revise this part in short. The homogeneous equation with the analytic coefficient. You know, you already know what is meant by the analytic function. And if the analytic function, because this is a homogeneous differential equation with the variable coefficients, that means here in this problem or in this theory, any section, each and every coefficient of the differential equation must be variable form, suppose. So if g is a function defined on an interval I containing a point x naught, or say that g is analytic to x naught, can be expanded in the power series of x naught. X naught means the initial solution, which has a positive radius of the convergence. Positive radius of the convergence means, suppose x naught is a 1 point. Suppose x naught is a point, we consider this center. Then the solution, general solution x, this distance x minus x naught, which is less than, suppose, r naught. This value is denoted by r naught. Then this condition is called as a radius of a convergence. Now radius of convergence, that is x minus mod of x minus x naught, which is less than r naught. So r naught is the radius of the convergence. See this, thus the g is analytic at x naught. If it can be it can be expressed or presented. See this, represented, spelling represented in the form x naught can be represented in the form. This is the represented. See this, काहीतरी स्पेलिंग मध्ये हे झालं होतं, represented. See this, represented. This is a represented, काहीतरी लिहिण्यामध्ये. Okay, it can be represented in the form of g of x is equals to summation k is equals to 0 to infinity ck into x minus x naught bracket raised to k. See this, and Ck is a constant and the series of convergence x minus x naught is less than r naught. Thus, we can obtain g dash, g double dash, okay, according to the series of the convergence. We have shown here is a note, there exists a solution in the form of power series expansion, and which is given by the interval on I x minus x naught which is less than r naught. Okay, we have seen this. And here if we suppose phi of x is equals to k is equals to 0 to infinity Ck minus x naught raised to k. Okay, good morning Saddam ji. Now we have to consider this example. Now suppose the second order homogeneous differential with variable coefficient is y double dash minus x into y is equals to 0. Given differential equation is L of y double dash minus x y which is equals to 0. That means L of y, actually this can be written as in this way also, because y dash term is absent, so y double dash minus 0 y dash or plus 0 y dash minus x into y which is equals to 0. This is the second order homogeneous differential equation. If we compare this equation with the standard form, that is y double dash plus a1 of x y dash plus a2 of y x y which is equals to 0. So here a1 of x is equals to 0, a2 of x is equals to minus 1. So we can say that these are the analytic functions. These coefficients are analytic for all the real value of x naught. Okay. Suppose x naught is equals to 0, which is the initial value. Now we have to found the solution of the series phi of x. According to the solution, I shall write this. Phi of x can be obtained from this, from equation 2. See here. Phi of x is equals to summation k is equals to 0 to infinity Ck into x minus x naught bracket raised to k. So according to this, phi of x summation k is equals to 0 to infinity, that is Ck in a bracket x minus x naught bracket raised to k. If we put the initial value k is equals to 0, and that we can write the expansion of series phi of x is equals to, if we put k is equals to 0, k is equals to 1, k is equals to 3, k is equals to 4, k is equals to 5, थोडे जास्त लिहा म्हणजे तुम्हाला समजेल. Then we get the phi dash of x after this differentiation. Again differentiating, we get phi double dash of x, means in this way. Now this summation we can represent by using the summation form with the general term. So suppose this is k is equals to 1. अगर हम ये सबसे पहले ये term adjust करते हैं, k is equals to 1, then this can be written as 3 means k plus 2, 2 means k plus 1. In this way we can write the condition that is equals to dot 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 in this way. Also x into phi of x is equals to c0 of x plus c1x square plus dot 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 c2x cube we can write. Therefore k is equals to 1 to infinity Ck minus 1 of x raised to k. आता अशा पद्धतीने हे जनरल केला. हे कशासाठी कॅल्क्युलेट केलं? वी हॅव टू फाइंड x into y, and मग we have to put this. Therefore if phi is the solution, then we can write this as a phi of x is equals to, phi जर solution असेल तर कसं लिहिता येईल रे मग? So we can write L of phi is equals to phi double dash minus x into phi, and replace this value, then we get this. If phi is a solution, then L of y is equals to 0. That means right side goes to 0. We can write right side is equals to 0. If addition of two terms is 0, that means first term must be 0 and second term must be 0. So we have written this. Now from equation 4 we can say that the value of this equation goes to 0. इसका मतलब ये है, equation will be true if all the coefficients of the powers of x are 0. So x raised to 0 means that is 1. So we get this equation. Okay. So we get this equation, x raised to 0 remove करून टाका म्हणजे हे equation मिळतं. That means we can obtain the set of equations regarding C, and we can find the values of C, C0, C1, C2 in this way, and we can write the solution of differential equation. ओके, हे अशा पद्धतीचं हे सोल्युशन होतं. आता यातला जो पार्ट, ॲक्च्युअली द लास्ट पार्ट ऑफ धिस चॅप्टर we will see tomorrow, that is Legendre equation. See this is the last part of this second unit. Then from Monday we shall start the third chapter. Okay, now if you have any doubt then you can ask. Okay, ह्याच्यात जर काही डाऊट असेल तर विचारा. फक्त सर्वात महत्त्वाचं आहे, अकॉर्डिंग टू द ॲनालिटिक कोएफिशियंट यू हॅव टू पुट फाय ऑफ एक्स इज द सोल्युशन इन दिस वे. या पद्धतीनं सोल्युशन तुम्हाला एक्सपान्शन सिरीजमध्ये, कॉन्व्हर्जन्स सिरीजमध्ये या पद्धतीनं सोल्युशन लिहिता येतं. हे लक्षात ठेवा, म्हणजे बाकी सर्व समजतं, बाकी काही नाही. बाकीचा थेरॉटिकल पार्ट आहे. ओके, जी ऑफ एक्स इज इक्वल्स टू दिस. वी कॅन राईट द एक्सपान्शन power series about x naught as a power represent in this way. Okay, now we shall stop here. जर तुम्हाला काही अडचण आली, काही क्वेश्चन असेल तर विचारा. उद्याला लास्ट पार्ट आहे लिजेंड्री इक्वेशन. ॲक्च्युअली लिजेंड्री इक्वेशन इज अ पर्टिक्युलर टाइप ऑफ इक्वेशन, differential equation. Now we have to solve that particular type of differential equation, and how to solve the Legendre equation. Actually Legendre equation is a particular solution. See this. Okay, now we shall